Welcome to ISCFDC EZOpt tutorial. In this tutorial, we will learn about the if, modify, and exit nodes. Let's begin by adding an input node, a calculator node, and an if node to the workflow and connect them. Then, in the calculator, we'll give a value that is not 0 or 1. The right branch of the if node, colored blue, is the pass or true branch. The left branch, colored red, is the fail or false branch. Before editing the node, a small reminder that an if condition comes in the form of if A, Boolean operator B, then do 1, otherwise do 2. A basic example can be if A is greater than B, then max is equal to A, otherwise max is equal to B. Now, let's edit the if node by double-clicking on it. This is the if node's option window. At the top, we have the node's display name. Below, under the pass condition title, we have the constraint, which is the Boolean operator in the if condition, having 4 options: greater than, less than, greater equal than, or less equal than. The next field is the value, which is the b in the if condition, a constant number. The last field is the tolerance, which is added or subtracted from the value depending on the constraint, subtracted if greater than and added if less than. Below the pass conditions is the expression section. To the left, we have the list of variables we can use in our if node's condition. And to the right, we have the expression field. This is the A in the if condition. In this field, we can use a variable, a constant, or a mix between sets of variable and constants with arithmetic operations between them. Let's put our input node as the expression, constraint as greater than, and value as 0.5. This is the same as saying if input's value is greater than 0.5. Now we need to decide what happens when the condition passes and what happens when it fails. For that, we will use the next node, modify. This node is used to modify a value of a parent node, a node that appears before the modify node in its branch. The modify node has a similar look to the calculator node with one addition, override node. This field controls which node's value this modify node may modify, hence the name. Let's add another modify node and connect one to each branch. In the pass branch, we'll set the override node to calculator and set the value to 1. In the fail branch, we'll also set the override node to calculator, but we'll set the value to 0. We can see that the icons of the modify nodes has changed. Now it looks like a calculator with a pencil on it. The modify node's icon changes according to the node we override. This way, we can differentiate between a normal node and a modify node. Now, let's set up a DOE. Then, we'll select a directory to run in and run the workflow. After the workflow finishes running, we'll go to the Analyze window and examine the results. Under case 1, the only case we have right now, we can see the results of our run. We can see in the results table that for all of the designs in which the input value was greater than 0.5, the calculator's value is 1, and for the others, that value is 0. Let's return to the workflow and change the failed branches modify node to an exit node. The exit node is an endpoint node, and it has no options. The moment the workflow reaches it, the process for the current design will end, and a new process will start for the next design. Let's run the changed workflow and see what happens. This time, we can see that for the designs where the input value was 0.5 or less, the calculator's value is 7, the same value we gave it at the start, while the other designs had the same results as the previous run. The exit node can be used in cases where a condition that is critical for the continuation of the process is not met, thus ending that specific design process and continuing to the next design. A good example is calculating time. If the calculated time results in a negative value, then there is no reason to continue the process and calculate the things that follow or use that value. This is it for this tutorial. Thank you for watching.